Positive world literature, world literature, but whatever we are doing in the project in ICRA and also the other projects, externally funded projects, which we have got for this important aspect, the results of which I will be sharing with you. So the outline of my presentation would be like the principles of remote sensing applications, because I understand many of you don't have the background of remote sensing. So a couple of slides on to introduce you to this important topic. Then different platforms of remote sensing and some case studies. As I said, most of the case studies is done by us. It could be ground-based or from satellites or through aircrafts. Whatever we have done, I'll share with you. And then what is visualized for remote sensing applications for future. So this is how I planned my presentation. Now, to start my presentation, any application of remote sensing is based on solar radiation. This is a fundamental aspect. Without solar radiation, no remote sensing application is possible. So that's point number one. And then in solar radiation, if you remember your college days, school days studies, something called electromagnetic spectrum. So I would like to again bring it to this today's topic, because remote sensing is based on electromagnetic spectrum. You see on the screen the electromagnetic spectrum is a very range from gamma radiations to almost like radio waves. But optical remote sensing, what we'll be dealing today, mostly deals with the visible radiation, that is 400 to 700 nanometers, what our eye can perceive. You must be all knowing this visible range. This range is 400 to 700 nanometers. There is something called beyond the visible range, is called infrared. You can see here it's up to from 1000 nanometers up to 2000 nanometers. To essentially to say that the satellites can see beyond our visible range. Our eye can perceive only this particular part, GR, but satellites can see beyond the visible region. That's called infrared. So let's see what are the bands and other more details about electromagnetic radiation in the subsequent slides. Now, before that, what happens when the sun rays fall on any object? So there are three possible reactions could happen. One is the part of energy, the electromagnetic radiation is absorbed by any object. It could be a plant, it could be rock or any wood. Whatever the object, the sun rays is falling, partly it is absorbed. A part of it is reflected back into the atmosphere. Number three, part of the energy is transmitted. It will go through, if it is opaque object, it is transmitted. To say there are three possible reactions. One is absorption, reflection, and transmission. Now, in remote sensing applications, the whatever sensor we use in satellites or aircrafts will measure only the reflected part of the energy, not absorbed or transmitted. The reason being, the reflected energy will have a lot of information. Is beyond our even imagination. So if you can measure the reflected energy, you can qualitatively or quantitatively assess the object, also the health of the object, which you will see in the coming slides. So the point I would like to say is the reflected energy is measured in remote sensing applications. Now the question is how to measure this reflected data. There are many ways. One is using spectroradiometers, is called scanning measurements. The other part is imaging part, which is done by the satellites. It is called sensors, multispectral, hyperspectral sensors. So there are two ways, as the scanning or it could be imaging. Scanning is mostly done by an instrument. It's called the spectroradiometer. You can see in this image. Then the images, the cameras, multispectral cameras. These are the cameras which are set up in the aircrafts or the satellites. Now, the different levels of measuring the remote sensing data. Starting with ground-based, we can use, as I saw in the previous image, ground-based measurements. It could be spectroradiometer or a small infrared camera, or even visible camera also is application of remote sensing. Then next level is airborne. Airborne is essentially at a height of not more than 500 meters, mostly by aircrafts. Nowadays, even the drones, we call unmanned aerial vehicles, that is airborne. The next level is the spaceborne, satellites. The satellites fly in the height of more than 1,000 kilometers from the Earth's surface, and we can imagine the kind of the resolution or the kind of cameras used in these spacecrafts, which can capture the images on the ground. So it is highly sophisticated. So the again coming back to this fundamentals is ground-based, airborne, or spacecrafts. So these are the images. What you see here, these two images are ground-based. As I said, drones and a helicopter or aircrafts, small aircrafts are used on airborne, and finally satellites. It could be Indian satellites or European satellites, American satellites. There are many set of satellites which you'll see in the next slides. Now, before going to the actual subject, I would like to start with this damage. Nature of damage by any pest, we name it, pests or disease, we can categorize into these four groups. One is defoliation. It will eat away the leaves, as you see in this picture here. Second part is sap-sucking pests. So you can see the damage. It can the sap, the respirating mouth parts, or it could be aphids, which will essentially reduce the sap content in the leaves or the other parts of the plant. The third part is pigment reducers, mostly the diseases. As you see, it can be leaf spot or blight or blast. These are called pigment reducers. Then cell damaging, particularly thrip kind of pests. They will damage the epithelial cells. So these four kind of damages: defoliators, sap suckers, pigment reducers, cell damaging group of insects. Why I showed this slide is there are different ways of detecting it in using remote sensing. Now, coming to the electromagnetic spectrum, we call it as spectral signatures or spectral vegetation spectral signatures. When you measure the spectral signatures, what you see on the screen, this is a typical kind of spectral signatures from a vegetation. This is from the plant. You hear the visible region, 500 to 700 nanometers. There is one more region called near infrared region, up to 1250 nanometers. Beyond 1250, we call it a short wave infrared. These three groups, visible, near infrared, short wave infrared, have different applications, which we will see now here. So visible region mostly detect the chlorophyll content or any other pigment reducers that can be detected in visible region. NIR region, cell structure. If you remember the previous slide, the cell damaging insects like thrips, their damage can be detected in NIR region. Short wave infrared region mostly for water absorption. If sap sucking insect damage, that could be detected in this particular region. Now, the question is, some of the insects damage one or either of or all of these damages. For example, thrips, they also cause damage to the cell structure. They also reduce the water absorption. So the combination of bands in these three regions is used for detecting pest and damage in remote sensing applications. Now, you will understand if you see some of the examples how to use this. I have taken 3 or 4 examples. One is a cotton leaf hopper damage. You can see in the bottom of the slide the different levels of damage, starting with A is healthy one, E is severely damaged leaf hopper damage. Now, these are different gradients. Now, if you record an electromagnetic spectrum using a hyperspectral radiometer, the signature looks like this. See, red is for severely damaged, green is for healthy. You see the differences here. Visible region, the healthy plants absorbs more because it has a lot of pigments. The reverse is the case in NIR region. Right? See the reflection very less for damaged plants compared to the healthy plants. So then short wave infrared, again the plant have a lot of moisture content. The absorption is very high. The reverse is case for the damaged ones. And you can also differentiate different grades. This is healthy. This is red is severely damaged. In between, grade 2, grade 3 can also be differentiated. So this is the essentially the way we detect the different severity levels using remote sensing. Now, take the other example, cotton millibug. You can see the difference here. There's not much difference in the visible region, but the NIR region, the difference is huge between different grades of infestation. Same time, not much difference in the infrared, short wave infrared region. So it's in the crop compared to the previous slide. This is the leaf hopper damage. This is the millibug damage. So within cotton crop, the signatures for different pests are different. So that's what essentially would like to convey. Now from here, for millibug, we identify the sensitive bands. That means the smallest change in the pest damage will cause maximum change in the spectral reflectance. That's called sensitive bands. It's not one band, as I said in the previous slides. It could be combination of bands. So this is where the research is. You have to identify the sensitive bands and at what combination it could detect the different severity levels. So that we have done it here. You can see for leaf hopper damage, reflection at 691 nanometers divided by reflection at 760 nanometers. Similarly, the different combinations have been worked out and they have been tested. For millibug, the bands and band combinations are totally different. So having done this, you can use straight away these bands, these few bands, sensitive bands, for assessing the severity of either millibug or leaf hopper within cotton crop. Coming to the diseases, plant diseases, I have taken here groundnut late leaf spot. You can see the color variation from healthy to the diseased leaf. And also at the bottom, the electromagnetic spectrum recorded from the leaf spot. This is totally different compared to the pest damage. Lot of change in the shortwave infrared because the water content is severely affected. The NIR region, because of this damage in the cell structure, this has been then we can see the changes here. Similarly, for mosaic in black gram, only visible region you can see the changes compared to other regions. The message is the signatures, so-called spectral signatures are very unique for any crop, within the crop, for any pest or diseases. The research, as a researchers, we have to identify first we have to characterize the reflectance spectra from the diseases, then identify the sensitive bands. Once you do this, then detection of these diseases using remote sensing is possible. Now the question is multiple pests or diseases within a crop. For example, chili here, we have at the same time we have got infestation of powdery mildew, thrips, leaf curl. So for all these things, for different color, you can see here, the bands, the blue one is the powdery mildew, the red dotted one is leaf curl virus, the other one is thrips. The sensitive bands are different for each of these pests or disease. We can see here. So again, the message is the sensitive bands is the key to detect pests and diseases using remote sensing. Having done this, we can publish these results in high impact journals like what we have done it in crop protection or computer electronics and agriculture. There are many opportunities because this is a new area. Not much work has been done, particularly in India. Abroad, in Europe and US, a lot of work has been done. But we have initiated this work and could do some work in a few crops. Now moving from the ground-based remote sensing to spaceborne. As I said, there are three platforms: ground-based, airborne, and spacecraft. Now we'll go to the spaceborne remote sensing. As I said, these space crafts are flown at more than 1,000 kilometers from Earth's surface, and you can they acquire the images from that height, and then transmit these images to the ground stations where we receive and then try to analyze these images for different purposes. In this lecture, I will be dealing only with the crop protection applications, what we have done from our institute. So before that, the different kinds of satellite data available in the world. One is publicly available images. This is free of cost. You can download it from the respective websites. There are several examples. Landsat series is from US satellites. Aster and Sentinel, they are from European satellites. This is the pixel size, means the minimum area on the ground. For example, 10 meters means 10 into 10 square meters. This is the minimum area the satellites can look from the sky. And then the revisit period. For example, Sentinel-2, when I said 5 days, it acquires the image from the same location every 5 days. It's called temporal resolution. So spatial resolution, temporal resolutions, they are the two factors which should be considered while acquiring the images from satellites. So now moving on to the commercially available satellites. You can see here there are many satellites for which we have to pay and acquire the images. The advantage is the resolution, very, very high resolution, up to 3.2 meter resolution, 2-meter resolution. But for that, you need to order before and then acquire the images. And the revisit period is something like revisit period. You have to, when you order, place the order. If you say, I want to acquire the images and so on, so date, they will acquire and then supply to you. But they are very expensive. These are all the previous slide, what you saw, remote sensing satellites abroad. Indian satellites we'll call IRS series, Indian remote sensing satellites. We have multispectral satellites, mostly 3 to 4 satellites. This is how the satellites, the images look like the Indian satellites. They acquire the images in 3 broad bands: green, red, near infrared, and short wave infrared. Only 4 or 3 bands. So when we get the satellite image from the, for example, IRS, Indian Remote Sensing Agency, they look like this: red, all black and white; green, green band. This is the NIR band. Now we have to use it in different combinations that we call color composite, laying one over the other. Depending upon the application, you can use red plus green or red plus NIR or all 3 of these. Then you get the color composite, which we use it for analyzing the pest or disease damage. Now, the spectral signatures acquired on the ground, and then the satellite images, how we are going to use. So what you see here is the spectral signatures of different crops: chickpea, red gram, sorghum, sunflower, safflower, which we acquired in Hyderabad, our own farm. You can see the difference. You can differentiate different crops based on signatures. For example, blue is the one which is typical to sorghum, and then the orange one is for sunflower. So one is crop you can distinguish. Then how we use it, these ground-based spectral signatures, when we acquire satellites. As I said, satellites acquire images only in 4 bands. They don't acquire the entire electromagnetic spectrum. It's called green band, red band. This NIR, there are 2 bands in NIR, B4 and B5. The point is, though they cannot acquire the entire electromagnetic spectrum images, within these bands where we acquire, they capture the required information. For example, green band, the background, you can see the changes. This much change it could be able to capture. Another band, and red band, again there's a lot of variation. And then the B4, the visible to NIR when it moves, that particular part is also captured. Then short wave infrared. So with these 3 bands, the combination of these 3 bands, as I said, explained in the previous slide, we can how we use these bands for detection of pests and diseases. we will see in the next coming slides. Now, for use of any satellite data, there are certain conditions. We cannot use it in all the applications. It's not possible. There are four conditions. One is the crop should be contiguous. If there is a too small area, there are many crops less than, for example, half acre or less than half acre, one after the other, the application becomes difficult. Then second requisite is availability of cloud-free satellite data. This is more so during rainy season, Kharif season, where most of the time it is with cloud. When there is a cloud, the images from satellites, it is not possible to acquire the images. Third one is the damage should be sufficiently large patches. In our experience, the damage should be more at least 30 square meters. If it is less than that, it's not possible to distinguish between healthy and damaged plants. The fourth one is the ground truth information. Sitting at CRIDAR, sitting at Bangalore, by acquiring the images, you cannot analyze the satellite data because unless you have visit to the particular area where the damage you want to assess, collect some ground truth data, then only you can interpret the data. So that's called ground truthing. So without ground truthing, we cannot analyze or use the satellite data for any purpose. So with these four conditions, we can use the satellite data. In our studies in CRIDA, we have used Indian satellites and Landsat American satellites and also the European satellites for several purposes. And we have some studies on cotton mealybug, rice VPH, leaf folder, and then groundnut leaf miner, and also chilies and maize recent additions. Now we will see the results of these case studies from our experience. So case study one is cotton mealybug. This is what you see on the screen is Google Earth image of one village in a district called Warangal district, which is around 150 kilometers from Hyderabad. This is a typical village where you can see the settlements, and besides settlements, there is a huge water tank. So the farmers draw water from this tank to grow the crops. This is the cultivated area in this particular village. Now, by having this tank, irrigated area is assured. So the whatever damage or the dryness or any kind of damage is essentially by either pests or diseases, not because of moisture stress. So one condition is fulfilled. Then we will see how this Google Earth image look like in satellite data. Before that, this is the ground damage. What you see in the Warangal district, the entire patches are dried. This is 2009, 10 years back. There was a this is an invasive pest, and it was causing severe damage for consecutive 3 years, starting from 2009 up to 2012. Many areas in this particular region were affected by mealybug. So we could able to do some ground truthing, collect the data, and then try to see whether we can detect it using satellite. So this is the satellite analyzed data for the entire village. You can see the dots, green dots, where we actually collected the ground truth data, and then the red patches are the ones affected by the mealybug. The green colored patches are the healthy ones. So with one satellite image of 2nd December 2009, the entire village damage of mealybug could be assessed. And then in terms of acres, around 230 acres is mealybug affected, and rest are all healthy. This is how with one image we can assess the entire damage in the entire village. Now the example case study 2 is groundnut leaf miner. This is Anantapur district. Again, it's around 250 kilometers from Hyderabad. This causes a typical burnt appearance. This is from rear the field, farmer's field, where we have visited the leaf miner damage on the ground. Then we collected some ground truth data and tried to analyze. This is the Google Earth image of the 2 villages where we acquired the satellite data and then collected some ground truth information. Now the results show that in these two villages, you can see you could even categorize the damage into severe, moderate, low, healthy. The acreage in each of the village is possible with the one satellite image of 10th October 2012. As I said, the correct the crowd tree data we could able to get, and we could able to collect the ground truth information, and then we could able to successfully use this data for classification of the fields. Now, case study 3 is rice leaf folder. This is in Kaithal district of Haryana, 2012 again. There was a severe outbreak of leaf folder, which was very rare. We can see that much severity of leaf folder. Since we have a NICRA center there, we could be able to go there, then collect the damage in the ground truth data from the farmer's field and try to analyze this using remote sensing data. So this is the classified image of the Kaithal district, entire, if not the entire district, 3 or 4 mandals. You could be able to classify. One is there are sugarcane field also there. The blue color place is the sugarcane. Within rice, we have 3 classes. One is healthy. This harvested fields. There's no crop there. This crop was harvested. Other one is the crop is very healthy but mature. It was yellow in color. Then leaf folder damage. So we are interested only for leaf folder damage. All red colored patches are the ones which are leaf folder damage. So in terms of acreage, so this is the data. The leaf folder damage, 27% of rice in this particular district is affected by leaf folder damage. And then other classes of rice also we can estimate using this satellite data. Now case study of 4. This is a chili thrips, started from 2016-17 onwards, devastating several parts of this country. Started with Karnataka, then Andhra Pradesh, and then entire countries are basically these chili thrips. So these are the top one is the satellite acquired spectral signatures. The bottom one is the ground-based spectral signatures. Both are almost similar. Then we try to use this for detection using satellite data. You can see that to the left, the before damage, this 10 January 2016, and then within a month, 9 January, the changes, the same area and the damage severity. You can see the severely is based on NDVI classification, and you can estimate the to the right. You can see the area. This is the red checked ones is 10 January, and then you can see how much it is spread. Almost more than 500 hectares is affected in this particular village, and then healthy area also you can estimate. Then the last example of using satellite data is the fall armyworm. You all know the invasive pest, which is causing damage. Started with sorghum maize, then moving on to many other crops. We could able to successfully use this. You can see the 2 indices we use, leaf area index and NDVI images. Before damage, you can see the 26th of October is before damage. 15th November is after damage. You can see the changes. These are all individual fields. It's not the entire village because it's sentinel data. This is sentinel data, which has resolution of up to 15 meters. That means we can even individual fields also we can see. So we can track the damage of this invasive pest within the field also. You can see between and after, before and after, and then we can also assess the damage also you can assess. So with this space-borne applications, I have concluded. Then we moving on to the last part is acquiring images through airborne applications. As I said, airborne could be either drone or it could be aircraft. The advantage of airborne remote sensing is, one is the cloud-free situation doesn't arise here because these aircrafts or drone can be flown below the clouds. The second part is you need not wait for the satellites to acquire the images. Whenever you want to acquire, just flight, acquire the images. Third advantage is the resolution. High resolution is very, very high, less than 1 meter resolution. So you can see even individual plants. So that's the advantage of airborne remote sensing. Now, not much work has been done in India, but Now people started working on it. We will see some examples. We had a collaboration with NASA where they have flown this particular aircraft in several locations in India. One is near to Hyderabad with the kind of bands you can see is a hyperspectral. We have more than 224 bands. If you remember the previous slides, the satellites, we have only 4 bands. And then you can imagine the kind of high quality of data is possible with the aircraft. It was flown during 2 phases, December, January 2015 and 16. So we collected the data during the same time on the ground, different crops wherever there is a damage, chickpea, groundnut, rice, and then even maize, drought, damage, drought, all these things we could able to collect data. When I said data means spectral reflectance using a radiometer, what you see this boy is carrying here, and then the SPAD, chlorophyll data. This boy is, you can see he is collecting the SPAD data, chlorophyll data, and then biomass. We just collected samples, bring it to the laboratory, estimate biomass after drying in the dry oven. This thing. And leaf area index. You can see the canopy analyzer. You can estimate the leaf area index and also the light interception. That's be useful for interpreting your data. And then PAR data also, photosynthetically active radiation. That's also possible using these gadgets. So the minimum requirement for ground truthing is these 4. One is reflectance, chlorophyll content, biomass, and then you can estimate leaf area index. If you have this, you can interpret the data. Now we will see some of the case studies where we use this airborne remote sensing. One is the chili damage. Here we can see that powdery mildew again thrips during the particular time in one of the village. The dark blue is the healthy patches, the healthy plants in the ground. Green is chili damage, red is powdery mildew damage. So you can see the classification accuracy is very, very high, up to 86%. You are sure that this particular damage is either by mildew or by thrips. Whereas in satellites, this much accuracy is not possible. Maximum accuracy is up to 50 to 60%. Rest all, there is a probability of not pest or it could be something else. So, but here in airborne, the accuracy is very, very high. Then we also had some orchards in Nalgonda district were affected by mosquito or due to nutrient deficiency or other root-borne damage symptoms that we could able to classify, and then you can see these different classifications where red patches are the damaged citrus plants. The other colors is given for different pests or diseases. Now, that's what the from aircraft 3 or 4 applications we would be able to do. Now, moving on to the last part, unmanned aerial vehicles. That's called drones in short. Now, drones are finding several applications. You can see there are a lot of public. If you just Google it, in agriculture, particularly, it's coming up. You can see Government of India also has initiated to use drones in agriculture. And earlier, the drone cost was very expensive. I was just Googling it to find out the cost. It was available even less than 3.5 to 4 lakhs. Earlier, the same drone was more than 10 lakhs. Now, cost is also coming down because the scale, many people started manufacturing drones within the country. We did not import it, mostly indigenously manufactured. So now the applications in future is for drones. Now, some of the state governments has initiated they're very proactive in using the drones. Tamil Nadu and Telangana, they have used it 2 years before, mostly for application of pesticides. Now, many states, after the Government of India has initiated a project, now many state governments have started using it. Now, as of now, application is mostly for application of pesticides or fungicides. This is a Punjab, Haryana. There also startups that started manufacturing and trying to use it for spraying application. And then one important development is the earlier to use drones, there were a lot of restrictions. We don't getting permission to drones is not that easy. But now Government of India, Ministry of Civil Aviation has made these rules very liberal. Now this is called something called digital sky platforms. You need not apply physically. You can simply apply online. Then you get a permission within a day or two, and then the flight permission because security reasons earlier a lot of restrictions were there. Now they have made some provisions to how to use it, at what height you have to use it, and then piloting license. Without licensing, we cannot use it. Now many departments or many state governments started trainings to issue the pilots. For example, Hyderabad, Professor Jaishankar, Telangana University started this training, 5-day training where they train and issue the license, pilot license for drones, and also institute called NIPHM in Hyderabad. They also started using, giving trainings and started issuing license for drying drones. And there are several drone schools which approved by the ministry, and then they all started issuing the licenses and giving trainings so that the use of drones will be encouraged in future. Now, there are many applications beyond the spraying use of using drones, which we are yet to realize because of certain constraints. As you can see here, it could be the soil health, or it could be plant health, or it could be a disease, pest. And then once you acquire it, you can use it in GIS platform. You can study the relationship between the soil, type of soil, and the nutrient deficiency or the pest damage, disease damage. All these geospatial studies is possible by using acquiring images through drones. Now, already it is there in Europe and other developing countries, mobile applications. You can simply fly the drone, real time, it will analyze and show you the patches where the crop is not healthy. And why it's not healthy, then since you are there on the ground, you can just go to the ground and verify what's the problem, is pest or diseases. For that also there are some applications. Take the image, then see whether it's a disease or a nutrient deficiency, and then use it for management practices. Now, future applications of GIS remote sensing, in a couple of slides I will share. Now, the government wanted that every farmer field in the country should be geo-referenced. That means latitudes, longitudes of each farmer's field will be made using aircrafts or drones, and it will be placed in the public domain. Anybody can, of course, with certain restrictions, so that you can download the shape files of the particular farmer's fields. Then you can use, once you have this geo-referenced maps, your application of the satellite data you acquire from either space or from aircraft becomes very easy. Now, once you have the this kind of maps, for example, this is satellite acquired image of particular one field, a farmer's field, and you see certain patches, red color patches, green patches, severe damages. Once you have it, then you mount it on a sprayer, GIS-based precision pesticide spray. The nozzles will open only where there is a pest damage, and it will shut off when there is a healthy crop. So it will start moving very slowly, and then it will open its nozzles, as I said, when there is a damage, and then it's called a precision agriculture. So you can save a lot of pesticides, and then you can also target the exact pest in the field. So this is already in practice in the developed countries. Very soon, I assume it will come in India also. Now, the smartphones, now many people are talking about artificial intelligence, machine learning tools. So a day will come using your mobile phone, you will probably will have some kind of attachment accessory. Simply click the image in the field, it will analyze what is the damage, what is the pest or disease, name of the pest and disease, and then a screen will pop up what kind of pesticides will work for this particular pest or diseases. Everything will be made easy. And then to encourage this, as I said, Government of India is very, very proactive. They call something like agri startups, use of drones. The young graduates from IITs or many other universities, they can come up with several applications. Government will provide seed money up from 10 lakhs up to 25 lakhs to encourage these young boys and girls to develop applications. Because we have, you have several crops, several agroecological regions, government agencies like universities or ICR institutes is practically not possible to address problems for all these localities. Now, we give it to the young boys and girls, they will come out with some applications so that the scaling up of application of drones, particularly drones, will see its years to come. Now, finally, what all you require to start a laboratory or a research project, if you are really interested, what are the minimum things you require? One is spectral radiometer. It need not be a hyperspectral radiometer because it is very expensive. What we have here, it will cost around 1.2 crores cost, but it's essentially not required. If you have a multispectral radiometer with 6 to 7 bands, which costs around 10 to 12 lakhs. This is essential equipment. GPS is also essential, but nowadays your phones are also GPS enabled. If you can use phones for acquiring the GPS data, it's fine. Then chlorophyll meter, SPAD meter, costs around 2 lakh rupees. Canopy analyzer, if you have it, it's very good. It's got some 5 to 8 lakhs cost. Infrared thermometer, without that also, if you have, fine. Otherwise also, with these two, chlorophyll meter, canopy analyzer, GPS, and then a radiometer, we can start the laboratory. Some software, PERDAS imaging software or GA software is a must. But now there are many open ended softwares are also coming. That also can be explored. But the software is also essential. To conclude, any remote sensing applications provides non-destructive and non-invasive estimations, mostly precise estimates. And then it will provide a synaptic view of large area. I can say a couple of villages in one image. And then its spatial attributions. That means what is the relation between neighboring field and the adjacent field, whether the pest is really spreading or not. All this is called spatial attributions. It's also possible with remote sensing. And best study is suitable for area-wide approach when you want to address district or village level problems. This is the best use. And then there is the possibility to detect the pest and the disease even before visible symptoms appear, because we have bands in NIR region. That will make our job easy. Then the scouting, those who are in the scouting business, where they take a particular route without knowing where the pest is. But if you have a satellite image or remote sensing aided scouting, you can exactly go to the area where damage is shown in the satellite image. You can verify, and then you can report it to the concerned government officials. And earlier it was using a satellite data or other things are very, very expensive. Now it has come down. Most of the images are now free of cost. As I said in my earlier slides, you do not even pay any cost. Other high resolution satellites are also not expensive. Around maybe 30,000-40,000 rupees, you'll get one image. Then now the era is not space, airborne, mostly drones, not multispectral, hyperspectral, more than 200-300 bands. That is going to be the future. All you need is little bit of training. It's not very difficult. 1 week or 2-3 weeks. There are many agencies who offer this training. And then there is one problem: is the multiple stresses. It is still a problem. There is a multiple stresses. Unless you have a hyperspectral data, you cannot distinguish multiple stresses within a crop. Then when you're using the satellite data, cloud-free satellite data, particularly during the rainy season, Kharif season, is difficult. Then your applications also becoming difficult. But now, as I said, using drones or aircrafts, this problem is also solved. Thank you, friends, for giving me this opportunity, and the organizers enabling me to share my experiences. Thank you. If you have
Thank
any
you,
doubts,
Dr.
Please.
Hello.
Yes.
Thank you, Dr. Prabhakar, for nicely explaining the role of remote sensing as well as airborne remote sensing and the very recent unmanned aerial vehicles like drones, their role in the plant health management, whether without climate change or climate change, their presence is going to be helpful for the plant health management. Thank you so much. Now I invite the participants, if you are having any doubts or clarifications, you can ask yourself, you can introduce yourself and ask the clarification. Anybody? Introduce yourself.
So good morning, sir. I'm Dr. Madhu from CPCRA with Kasaragod, sir. So I have a question on because as you said, the single pest or single disease damage can be detected using remote sensing. So you also said that multiple stresses, it is difficult to detect in an area. Then how best, because for us everything looks same, because from seeing it from a distance, the damage from thrift, the damage from whitefly, damage from leaf hopper, other sucking pest, everything looks same. But how do you conclude, even for single damage, this is from exactly from leaf hopper damage, this is exactly from specific pest damage? Because how what is the accuracy, or how precisely you can say this is exactly from the same pest which is exhibiting that kind of symptoms like that, sir?
Thank you, Madhu. That's a very relevant question. There are two ways of doing it. One is, you might have seen one of the slides, hyperspectral imaging. I have given Chile example, okay, where the spectral signatures for each of the diseases are very unique. In Chile, I have shown you the thrip damage, then powdery mildew, leaf curl. So it is possible when you have a hyperspectral data. Yes, when you have a multispectral data, as you said, the multiple damages is difficult. However, if you have a very good ground truth data, because as I said, ground truth is a must. If you have ground truth data, you are the expert. See, the person who is going to the ground, he is the expert. We can distinguish whether it's the chili damage or any other nutrient deficiency. If with this kind of ground truth data, you can probably rule out the other damages. There's one possible, but without ground truth data, without hyperspectral data, in some cases, the multiple stresses is difficult.
So to put it in a simple, as you say, saying that the ground truth information is must, and you can feed it to the software. Then only we can go for remote sensing to detect this particular symptoms.
Yes,
that's exactly what you are saying, sir?
Yes, exactly.
Oh, thank you, sir.
Okay. Yeah, okay. Thank you, Dr. Prabhakar, once again for sparing your time and briefing about all remote sensing and its role. For the information of us, he will be representing our India also at international level for negotiations or something related to climate change mitigation and other things. You may be seeing in other media also. With this, once again, I thank Dr. Prabhakar for joining and sharing your views regarding remote sensing and plant health management. Thank you so much.
Thank you, sir. It's my pleasure.
Thank you. Thank you. Dr. Amarender. Yeah, next we'll be having, and yesterday somebody is asking regarding this statistics and pest forewarning and modeling, forecasting as well. With this, that we are having Dr. Amarender with us. Dr. Amarender.
Namaskar, sir. Can you hear me?
Namaskar, ji.
Can you
Just a
hear?
minute. Yeah, here, sir, around 22 participants from
great.
12 states are there. This is a inter-school on impact of climate change on insect pests and other pest diseases, natural enemies and pollinators. As a part of this, we requested you and we thank you for joining with us for taking forward this pest forewarning and forecasting at that lecture. Coming to the for the benefit of the participants, here with us Dr. Amarender Kumar, whose field of specialization is statistics, crop modeling, technology, forecasting, and impact of climate change and pests and diseases dynamics in crops, which is very, very relevant to our winter school topic. He did his MSc from agricultural statistics from ICAR-IIHR in New Delhi, the PhD in statistics from MD University Rohtak, and his PG school faculty in the discipline of statistics. Presently, he is in academy unit, and with this, he has very vast experience in pest forecasting modeling. Some of you may be very interested in that. After listening to him, if you have any basic doubts, you can get clarification from him. With this short introduction, I request Dr. Amarender Kumar to go ahead.
So, thank you very much. Can you hear me?
Yes, sir.
Yeah, thank you. Thank you, sir, for giving my introduction to the participant. I will talk on the whatever the experience I have learned during working in the area of the forecasting. Basically, that things I want to share with you my learning experience, so that you can also get idea what type of problems I face and how to get try to resolve this issues. Hope now I'm going to share my screen, which may be visible to you, and so that I can give you my presentation. Can you hear my lecture? Can you hear this my PowerPoint?
Sir, it is visible. You can go to slideshow mode and start that one.
No, it is already in slideshow mode.
It is some of the screen is awkward with outline of lecture. Is it visible for all of you? Yes, sir, you can go ahead.
Is it?
Yeah, it's visible, sir.
No, it's visible.
Yes.
So I will talk on the epidemiology and warning of the insect pest and disease vis-a-vis the climatic changes. Before that, just I will tell about why this forewarning is important, and what are the various things which I want to share with you in this lecture is like an introduction, type of models that may be statistical and the machine learning, the development of warning models, then upscaling of models by the satellite data, the climatic change adds and its impact on the pests and disease. Then we develop some warning systems, predictions and identification. That is a major one of the product you can say when we talking of the warning. So develop a model, and it does not use to the end user, maybe used for the publication and other things. But if we develop a product like a forewarning system, so that end user, maybe our farmers, our policy maker, can get the benefited from these systems, and that can really help to reduce the cost of cultivation of the farm modeling. In this system, we will try this some forewarning system, development of forewarning system, and that we will share with you in the detail. Before that, I will go in the detail. Just you see the genesis. If you think of the importance of the forecasting in agriculture systems, it is a very, very important nowadays. So because if we go for the policy decision or policy makers, these predictions or forecast is a very useful in terms of the planning, formulations, implementation of policies, with respect to the food procurements, distributions, etc. That information on the productions and yield of the crop well in advance is a very, very important factor in this predictions for the government policy decisions. So forecasting can be done in the two way. Like one, we start with the predictions of the crop yield, and then another is the forewarning of the infestation of the pest in the crops. Under this forewarning systems, the it will help to timely remedial measures may be taken up by these forewarning systems. Then crop or the loss assessment is done through the forewarning system, and this will help in the farmers to get the unwanted spray of the pesticides, and that is reduce the cost of the cultivations of these things. So therefore the forecasting as well as the forewarning of the system is a very useful in the agricultural systems, and nowadays the area of the forewarning become very, very important because of these two reasons. And another aspect is very important nowadays, the climatic changes. So all of you know that what is the climatic changes, and there may be a various lectures and course on the climatic changes that I will not share with you, but I will tell some basic things and some statistical method in which we can, how much we can detect the climatic change. Is it there? Is it, what is the quantity of the climatic change based on the local specific? When we're talking the climatic change, we are talking at the national level or the international level. But the agriculture's impact is on this climatic change is done at the very, very small level, maybe the district level, maybe the block level, or even the village level it was there. So how this type of descaling, the downsizing the climatic change with till to the block level, how this climatic change make an impact. So that I will show by some statistical method how this quantify can be done through this system. So I will demonstrate one exercise also and demonstrate my whatever the work which we done in the climatic change. So now this under climatic changes, new pests and disease are emerging as an added threat to the productions. So maybe all of you know that because you are, I hope you all of you are from the biological sciences, that at a 20-25 year or even the 30 years back, if you say they are the some pests which is a very minor in the nature, but now they become the very major in the system. Similarly, those which are the major at that place nowadays become the minor. So how these changes take places, what is the its impacts? The one of the major factor we consider is the climatic changes. So that is the importance. So how these changes in the climatic leads to a minor to major or major to minor. What are the various factors? What are their physiological aspect was changes, and then statistically how it can be think on the visualize in that manners. So therefore, the climatic change scenario is one of the major factors which nowadays take care of in our the new research areas. Then the forecasting of various aspects on the pest and disease are the become very, very essentials with of this aspects. So just if you see this, I want to show some data. Based on this data, you will get understand importance of these losses of due to the pest and disease. If you see, so this is data which is generated by the FAO. So I got the data world over. The damage by the pest of rice, wheat, and maize alone cost $60 billion per year. Now you can imagine how much losses was there. Here I've considered only the three crop. Means data is for the three crop, that rice, wheat, and maize. And if you see this damages by the disease, it's damage about 125 million tons of rice, wheat, maize, potato, and soybean each year. So you see the quantity of the losses by the disease and the pest. If we can save these damages by 20 or 25%, we can save a great we can save a large number of the production, as well as we can save the money, because this can be utilized for the spraying of the pest and disease. This is the one data which is very important in nature. There is another report which is published in the ASHO-SAM study in 2014, published in the Hindu Times of India on 14 February 2015. They said that at an Indian level, if you think about 50,000 crores of losses was there on the annual basis in India. I'm talking only this in India. So this estimate is an underestimate, what I feel based on this study. It may be close to 75,000 crore annually losses due to pest and disease. And to control this pest and disease, there is one report by the DPPQS, which is published in the Lok Sabha in 2015. They say that the chemical pesticide which is utilized in the agriculture system is about close to the 60 metric tons. Now, to control the pest and disease, and it has an impact on the environmental effect also. So you see how much quantity of the chemical pesticide was sprayed across the India, which is, this is report say, about 60 metric tons of the insecticide and pesticide were utilized. So can we visualize the model or the process or the phenomena in which we can save the crop to a great extent so that the losses can be reduced? We can use the optimal spray of the chemical pesticide, and which is in turns save our environmental effect also. So there is a factors which we can include is the modeling aspect, in which we can take care of the weather factors in our backend, and then based on this the cause and effect relationship with the crop, pest, and weather, if you see, that can be done in this model. But it is not so simple. Just I will tell you an example, and I hope you will understand based on this aspect also. Just I will show one exercise. Just a minute. Can you view this whiteboard? Hello?
Sir, you can
Yeah.
see. Yeah, we are viewing.
Just I will tell one exercise so that you can get. I want to study the pest. Something wrong happened. I think there's some issue in the board, so just time to rectify it.
Okay, sir. We'll wait.
Sometimes these electronic gadgets
Yeah, it's
useful also, and
No.
sometimes it.
Yeah. Sir, now we have unshared the screen.
Yeah, just a
Okay.
minute, just a minute.
Okay. Again, you can try.
So I hope now you can. See
Yeah,
my
now
screen.
it is the whiteboard is visible, sir.
So just I will tell one forecasting. So I want to see the crop, pest, and disease. Sorry, weather.
Weather. Okay.
So now I want to see this model. So basically, why it is important, that's I want to tell with you. Like I will start a model in which I want to develop a predictions model, forecast model for rice crop. Just one, this is a forecast means forecast
Sir,
model for
am
yield
I
I am talking.
audible,
At
sir?
the district level.
Hello?
Hello, can you hear it? Hello?
Hello, am I audible, sir? That
Yeah,
Amarender?
you are audible. You are audible. I am audible. हेलो मैडम अभी जस्ट एक क्लास चल रही है मैं थोड़ी देर में कॉल करता हूँ आपको ओके मैडम ठीक है हेलो कैन यू हियर मी हेलो
Hello, Dr. Amarender, am I audible?
Yeah, you are audible. Can I hear
Hello?
me? Hello?
Speaker is on.
Can you view me? Can you hear me?
It's connected. Just
Hello, Sridhar sir. Can you hear me?
Screen as a backup. It's ready.
Can you hear me? Hello, Sridhar sir. Hello.
Sir, am I audible? This is Sridhar.
Yeah. Yeah, you are audible. I am audible.
That's just check.
Hello.
Yeah, just to go and have water.
Can you hear me? Hello, Sridhar. Dr. Sridhar. Hello. Can you hear me, Dr. Sridhar?
Hello.
Sir, hello. Can you hear me? Hello.
There is a small.
Oh, ho, ho. Okay, okay, okay. No issue, no issue. Okay, okay sir. No issues, no issues.
Recording in progress.
Hello. Yeah, you. Okay, 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 okay. Nice.
Sir, you can share your screen again.
Just a minute. So can you,
Yes, sir. Now we are
is visible?
white. We
Yeah.
are again back into that white mode. Please go ahead, sir.
Okay.
Oh.
So just I want to see the crop pest weather. Basically, it is a triangular shape. Now, just I will tell one aspect on this what are the problem exist when we develop a crop pest weather relationship model. So just one example that I will tell you. Suppose I want to develop a model for a crop yield predictions. Crop yield predictions for rice crops. Let it be a rice crop. So can you tell me how much duration of the rice crop in time, in how much time it will take to grow a rice crop? Hello?
How many?
So just I will
120. Yeah. Some edit 120 days, sir. One variety they mentioned.
So maybe 120 days, say that it is a 120 days.
Duration crop.
It means it is a about 4 months.
Yeah.
Suppose now I want to predict or forecast the crop yield when the crop was harvested, no use. So we have to forecast at least a 1 month before harvest.
Yeah.
Okay. So I
Oh.
want to forecast at the crop when it was a 3 month old. So I will utilize the data for. So now your question comes, I want to develop a forecast model using the weather factor. What are my cause and effect relationship? Cause and effect relation means, as you know much better than me, and because you are the agriculture, I am not from the biological science. Basically, I am from the mathematical science. So so that the crop yield is directly depend upon the crop growth, crop germination, different crop growth stages. So it means that the effect of weather is starting from the time of sowing till the time of harvesting. Are you agree with this statement? The effect of the crop yield on the weather is starting from the time of sowing. If the time of sowing weather was not congenial, you may reduce the 10% germination. So it means the yield will loss. Are you okay with this statement? Hello?
Yeah.
Hello? Can you hear me? I hope you are audible. Hello?
Yes, sir.
Yeah. So it means that we have to take a weather data from the time of sowing, to time of forecast. Means 3 month data we will consider. As you know, the weather data on the daily basis or monthly basis or weekly basis, which you consider is the most important. Whether we should consider for the daily basis, monthly basis, or weekly basis. Whatever the learning we learn or get experiences from the working in the this forewarning system, I found that for the crop yield predictions, we should consider a weekly data, but for a pest and disease infestation, we should consider a daily data on the model development. So now I will consider here.
Just I have shared this Zoom link. Whoever can go. Yeah.
We can join.
So I will consider here a weather data on the weekly basis. And what are the most important weather factor are the first is the maximum temperature, max temperature. Second is the mean temperature. Third is relative humidity morning. Fourth is the relative humidity evening. And the fifth is
Yeah, I'll have to just mute and follow.
fifth is rainfall. Fifth is the rainfall. So I found that there are 5 variables are most important factors. And if we have 3-month data on the weekly basis, so how much weather data we will get? 3 into 4 into 5. 60 variable. Are you getting my point here?
No, sir.
If we have 3-month weather data on the weekly basis and data on the 5 variables, so it reduced to a 60. Number of variable is a 60. All of you are agree? Hello?
Yes, sir. You please go ahead. Yeah.
Yeah. If all of you are agree, then it means that number of observation. So if we go for the yield predictions, we does not have more than 30-year data. But now we have to estimate 60 variable. So the major problem in agriculture comes here. We have N is equal to 30, but P is a 60. So can we develop model? The question comes. Now we have N is equal to 30, P is equal to 60. N is the number of the data in which we utilize. P is the number of variable to be estimated. Can we develop a model? Any student? I'm not asking the Sridhar sir. Any students? Can you tell me? Under
On
this
behalf, I will
scenario-
tell. Yeah. Is it enough or something else is required?
No, that's students. Can you?
Yeah, I'm asking them only. You can,
Yeah,
whatever you feel, just you can tell. It is a
Yeah, just you tell
learning
me.
experience. If you tell them it is wrongly, all of us will learn from that wrong thing. Any answer?
No.
Yeah, they are not sure, sir. Please
They are
explain.
not sure. Okay, that it's made good. So it means that just you see, normally when you are at a all of you are master degree, they are doing master degree or maybe some
PhD, sir.
professor
all,
or lecturer. So all of you
in
have
different
some
subjects.
basic information on the statistics. This is because of inter school, so all are faculty member or
Yeah,
scientists.
all are faculties only.
Yes. So it means that under this scenario, there is a basic assumptions in the statistics. Our N should be more than N must be more than P. But in agriculture, if you develop the model, lot of people develop the model based on this scenario. In this scenario, what is the degree of freedom? Degree of freedom, what we known as N minus P. So in this equation, N minus P become the negative and our F value become infinity and R square become 1. So when we develop this model, we find that R square become 1. Or say that yes, this model is a very good, but theoretically it was a very 100% wrong model. That is my point on. That's the reason this demonstrated the basic things in the statistics. Normally, these things we never seen in the model. And this make a great impact in the predictions purpose. So under this scenario, we cannot develop the model. So what are the scenario? How we can go develop the model? So now I will show by so under this scenario, how we can develop a model so that it could consider the pest, it could consider the weather, it could consider the crop. So it is a multi-dimensional modeling in which there is a triangular shape in which the one is the crop, one is the pest, another is the weather. And you know, when crop will be there, definitely weather pest will be there. When there is the crop will be there, the congenial weather is a very important for development of the progress of the pest as well as the development of the crop growth. So these are the very important factors while we developing this model type of the model. So what we can think on the direction. In that direction, whatever the process which are utilizing, that I will going to share with you in this next slide. So just it will take time. Why it's not opening? What happened? Just a minute. I think there is some issue.
Now only one is there.
Just a minute. That's, I think there's some issue in my PPT. It is not opening.
Okay. It is not because two windows are open. It is not the reason, sir.
No, maybe that is not issue.
Okay.
So I think now, can you view this screen? Is it visible?
Yeah, it is visible, sir. You go.
So based on this, whatever the thing exercise, I will tell you that what should be my priority, what should be my candidate things should for the forecast model. So the priority we should know about any epidemiologically and forecast model in the plant disease and the pest and disease. So priority is that knowing occurrence of the disease and the insect based on the crop in advance. That is a 7 to 10 days ahead of the actual occurrence. Means we should know the priority when we should have to predict that thing so that we can take a control measure. Then we should develop a warning system that identify the time, alarm zone, model development, and based on this forewarning system, we can spread a statement. If it is the pest and disease more than the threshold, we should go for the spray. Otherwise, there should not be a spray. Then if there is a spray, what should be our management? That is a pest and disease management. That is what is the economic decision? That is a pesticide schedules for the season, for the reason, particular crop against specific maintenance expected, and farm economics. There are things we have to think on this epidemiologically as well as the forecast system. Then yield loss assessment. And the most important thing, where to use forecast model. That is a use for the candidate disease and pest to be forecasted. So what is my candidate disease? The disease or the pest, which is really a major problem at the state level or the national level. So we cannot develop a model for a very small area. If you develop this model, that may not be work very finely, because the phenomena which we captured in the model, that is take care of the whole agroclimatic zones, and the whole agroclimatic zone is a very big area as compared to the very small if we develop a model for a small area. So that reason, when we develop a forecast model, it should be a candidate crop or a candidate disease or a candidate pests. So this I will skip this. So now the crop pest relation we developed when. So we find that the weather is the factor which affect the crop during the different stages of the development. Similarly, it also affect the pest and disease progress. And if you take as an example, I will tell you, it requires a large number of the parameters which have to be evaluated from the data. And because of the non-availability of the long series of the data, then it is a very difficult to develop a model. So what we started, so we work in that direction, that this can be done through some indices development. So how these indices can be developed so that whole weather data can be utilized without losses of any informations, and we get the less number of the independent variables, so that model can be developed, and based on that model we can see the prediction ability also. So let's you see, most of our research workers or early workers have utilized the regression models, but in the regression models it has an advantage, it has a disadvantage also. Suppose if in this model, if our n is more than the p, then the model cannot be developed. But if we take or we select a variable based on the importance of the variable data, then physical meaning becomes very difficult. So take care of the interpretation of the physical meaning of weather data. We develop two type of indices. That is, we develop a suitable weather indices which is used in the development of model, and that model will utilize for the model development. So how these indices was developed, taking the weather data from the time of sowing to the time of harvesting. So now if you see the data availability, the historical data, if you see for any pest and disease, we will get a data up to 10 to 15 years at one point of time, or a crop season. So in this case, we will get the overall status, pest or disease intensity, and the crop damages. Sometimes we have the data for a 5 to 6 year at a periodic interval. Means after in a whole season, we get a 5 to 6 data in each season, and this type of data we have to 5 to 6. So under this scenario, we can develop a natural growth pattern, and based on this, which can be connect with the weather fluctuations, and will come out with a model. But if at a one point of data for a 5 to 6 year, model could not be developed. So sometimes it happens that we have the qualitative data, and which is of the 10 to 15 year, or the mixed data, maybe qualitative, quantitative. So in this case, the logistic type of model will be very useful for the development. But normally in the MSc and PhD thesis, we will develop only a 1 year of the data, maximum of the 2 year of data. In this type of these developed data, the model development is very, very difficult, cannot be done. But within year growth model can be utilized when we have the data for the 1 year or the 2 year. So these are the data availability. So if you have the 10 to 15 year, we can develop a model very easily, very effectively, and that model, the performance of that model is a very good. But if it is for a one point of time for 5 to 6 years, we could not develop. We should not attempt this development model. Then another is the qualitative data. If it is here, we can utilize. Now the question comes, which of the variables we are interested for the model development? So there is a large number of various variables is there, but whatever we learned from the last 7 to 8 years while working in the pest and disease forewarning, I found that the few are listed in the screen. You can view it, but the blue color, if you think on these three models, if we develop a model for a maximum pest population or disease severity, the time of first appearance of disease, and the time of maximum population and severity of the disease, pest and disease. These three information will help to create an advisory. So how we can get an advisory? So if we think on the time of first appearance of the pest and disease, this tells us the monitoring of the crop. So we can develop a model in which the first appearance of the pest and disease can be seen in our field. Based on this model, we will start monitoring the pest and disease. Based on the time of maximum population, if we develop a model based on the time of maximum population of severity of the pest, we can get that time when the peak population of pest and disease will be there, and what is the maximum intensity which is done in the maximum pest population. So we can get an advisory at what time the maximum intensity will be there. Based on the maximum intensity, we will group into the different cases like a threshold value. If the maximum pest or disease severity is more than the threshold, then we should apply a control measure. If our maximum intensity is less than the threshold, then we should not apply a pest or apply a pesticide in the field. This exercise we attempted in the mustard crop, we attempted in this chickpea crop at the ICAR set, and we come with a result that is a cost and benefit ratio. We can save at least a 2 to 3 spray in the mustard aphid, and spraying of the 2 to 3 reduce the cost of cultivation as well as the environmental hazards in that particular locations. So if we advise them based on these three models, what is the proper time for the control measure? If based on the model, if we say that the population is more than the threshold, we should apply the pesticide, or if it is less than the threshold, we should give an advisory to the farmer for a particular locations, for the particular crops, we should not apply any insecticide and pesticide because based on the historical data, based on the current weather data, we will find that this year there is the intensity will be not reached to a threshold value. So this type of advisory based on these three variables can be viewed, can be seen in the model development, and which will be help in the saving the crop to a great extent, as well as take care of the pest and disease well in advance. That is a control measuring. Besides this, we can develop a model on the weekly monitoring of the pest and disease progress. Suppose after the reaching a peak, how it will start decreasing or not, the occurrence and non-occurrence of the pest, and the extent of damage. So based upon my research work, we can identify the variable of the interest, and based on whatever the data which we have, based on that we can develop a model. So what should be my cause of explanatory variables? This is the most important factors which we consider. But my thought is that we should consider the explanatory variables which is easily we can get from some sources or some government institute or organizations. Like it is a very difficult to develop a simulation type of model, because that require a very huge input data. And this, if we develop a model for a farmer's fields, that data we cannot get it. So what my plan is that if we get a weather data, which is collected by the either the State Agriculture University or the IMD or the any satellite data, that data we can utilize to develop a model, and that is a very easy to get from the particular sources. Maybe the IMD. IMD provide the all India district-wise data at the each locations. So why not utilize this model? There is another data availability that is known as the spatial data, satellite-based agromet product, which I will show, which we develop one model based on the satellite-based data for the different crops, for the pest and disease, that and based on that we develop a system also that I will going to show to you. In this case, we will consider only the weather variables and the crop stages, that is the ages of the crop when we to forecast how. So using these two factors, we develop a model, and based on that model, we come with some conclusion. So as you know, that if we think on the various methodological aspect, various approach was there, starting from the regression approach, growing degree decomp methods, then the complex polynomial through GMDH group method of data handling technique, deviation method, model for the qualitative data, non-linear models. Nowadays, this soft computing technique is a very, very important. And based on this soft computing techniques, we can really get a good predictions ability. And but it has one disadvantage also. For any artificial or any soft computing technique, ANN based approach, we require a huge data set. That is a very difficult to get. But we will manage to get some set of data, which I will demonstrate in the practical exercise, so that using that data, we can get a good model with the very accuracy. Through a very good accuracy, we can get it this predictions. We can try to resolve the predictions of the pest and disease to a great extent, that I will demonstrate during the course. These are some rules that are there, because their thumb rules are there. So based on this, also is available in our literature. We also develop a thumb rules, which is utilized for the February. Just example, if we go for the potato late blight, it is a Trivedi et al. In 1919. They provided based on the these three conditions, if it is there, there is a chance that the favorable blight will be occurrence. These are all are subjective in nature. So what my plan, we started working in the area of the regression model, then based on this weather indices based regression model, and then nowadays we are working on the artificial intelligence based model, so that model can be developed to a great extent. So before that, just I want to show some glimpses of the model, so that there should be not a monotonous lecture type is there. So I will now going to demonstrate some. Can you view this screen?
Yes, sir.
Yeah.
With ICAR-IIHR logo, that one. Yeah.
Yeah. So just because there is one interesting thing that I want to share with you.
Right.
So, just I will tell you, if you draw a graph between the interest in teaching, or take interest in the class, interest in classroom. Sorry, this is the time, and this is the interest in classroom. When a teacher start a class, and now if you want to see how the interest in the students flow from the 0 to 120 minutes. Can anyone tell us how this graph look like? So initially, if you say the interest will be very low, then it reaches to a peak, and then suddenly it starts.
Then that can be considered as a break times, huh?
So this time, you know what is the time? This time is known as maybe at the 55 minutes.
Yeah.
So you know what is the duration of the class? Always a 45 to 55 minutes.
Yeah.
Got it? So this is the break time.
Yeah.
And you see the time, already 1 hour is there. So
Yeah.
that's the reason. But because the time is a scarcity here, so I will not break. I will continue in my exercise. So
Yes, sir. After 15 minutes, can we take a small break, sir?
okay, no issue. That is not an issue.
Okay.
So
okay.
this will very helpful to you, because in this case, whatever the methodologically things, because it is very difficult to tell the detail in the methodological, but you will get the awareness.
Right, right. For idea purpose, it is good.
So
Example.
I will directly demonstrate how this model development based on the different characters will be helpful to show the models, its ability. So in this system also. So this is my one project which we initiated with the Space Application Center, Ahmedabad. And as you know, getting a weather data is very difficult from the various IMD and other things. So in this project, I get a special setmat data. Special setmat data means we are getting a picture images from the various satellite base, and that was converted through some algorithm. That was converted into some algorithm to drive the agromet data, which is a 2 meter above the surface. So normally when we go to the agrometeorological data, it is a ground surface data, but the satellite based data is a 2 meter away from the grounds. So what we did it, we consider that data, because it is can be this type of data we can get at all over India level, even where the 5 by 5 kilometer means the area of one village, we can get these type of data from the village level data. And therefore, any grid point we can get this data, we can initiate the working on this model, and then there should be we work on the equal platform. So what is the difference between the setmat data and the agromet data? Through some statistical algorithm, we develop a correction factor and we put all data at an equal platform. And then we compare with the agromet data, and then that setmat data can be utilized for the predictions of the pest and disease. This is my objective in this program. So just you see, this is the different set of the data, and we develop a model. You can also view it sitting in your room or your laptop. Just you put sbfs.iri.ris.in. It is a satellite-based forecast system. This what I put it as a SF. The link is a sbfs.iri.ris.in. You can note down and you can view it. So there is the predictions model is there. So in this case, what I did it, so we consider here the model development for a crop yield as well as the pest and disease for a mustard. So you see for cotton, we develop a aphid, pink bollworm, thrips, jacid, and cotton boll. Similarly, for the different crops are I've considered, just like you see, chickpea. So these are my target crops. Chickpea, cotton, mustard, peas and pea. So if it is in the chickpea, if you see, similarly, if you go for the cotton, we also get the pink bollworm, then yellow, then mustard crop, we develop a model for the mustard aphid for whole Rajasthan, districts-wise data from the Rajasthan. So you see, in this case, these are the yield data. So we develop a district-wise model for whatever the district from which the chickpea was grown. So I found that there is a 26 districts of Madhya Pradesh where chickpea was grown with the acreage of, means where the total area under crop is more than the 50% of that crop is there. That reason we choose 26 districts only. There is other district where yield was, means production was there, but the area under is the very low. So I consider the 26 districts where very good amount of the area is under the chickpea. So we develop a model on that various districts based model in this model. So just now, if you go for my predictions model, so predictions model also tell the pest and disease effect. Just you see, this will tell sorry, just a minute. These are my yield predictions model. So I selected chickpea for, if we go for the yield, it is tell us which locations which were there, because we develop a model for chickpea only for the Madhya Pradesh. So there is the Madhya Pradesh list was there. So if we select Madhya Pradesh, all our districts, for which all 26 districts where model was developed. So let it be a Gwalior. So Gwalior, if it is there, so we develop a model using the data from the 2001 to 2014. And then 15, 16, 17, 18, 19, these are my out of the sample data, where forecasting we can be done through this model. Suppose if we go for the 20, so it will tell us the basic informations. So it tells my basic data also. So what is my constant, what are my variables? And if you plot it, so it also tells the graph, how it was look like. Because after that, this graph, still it is a project is going on. These are my observed. After that, I have to match with the observed and predicted. And for the last some districts, because it is a difficult to get sometime the yield, the forecast, this observed data. So for the 5-6 districts of Rajasthan, we did for the, especially for the mustard crop, we did it, and we find that this model accuracy is close to the 85 to 95%. So observed, the forecast error is a very good one in these cases. And now you see our predictions of the observed and predicted till the data is available. It is up to the mark. When it is reached to a peak, so prediction is 178. And similarly, in 2010, observed is a very good agreement with the observed one. So under this type of model, if you see, we can get a good amount of predictions, and that can be shown to the user. So just you see this chickpea. Now I will show the pest and disease, especially for the pest and disease for the where which developed. So under this mustard crop, we develop a pest and disease for mustard crop, cotton crop. So you see, in this case, there is a 23 districts, 33 districts of the Rajasthan. Then we utilize 22 districts of Haryana for a pest forewarning in this case. So under mustard crop, we are consider the aphid and the Alternaria blight. These are the one is a pest, other is a disease. So if you see this aphid, so there is a 3 districts are there: Bharatpur, Haryana, Rajasthan. So there is I have written the Bharatpur. Bharatpur indicated the agromet data. So I compare with the agromet data with the setmet data. That's reason Bharatpur, because that is a basic All India Coordinated Research Project, and the mustard was there. This Mustard Research Institute was there. That season we developed a model for Bharatpur using the setmet as well as the agromet data. But now if we choose the Rajasthan data, all our districts from the Rajasthan is there. So if we choose any of the districts, it will tell us the model. So it will tell the model. So in backend, different models. So just you see, we develop a model for a crop age at the first appearance, crop age at the peak population, and the maximum population. And based on these three models, we can give an advisory. So if I select all, so it will tell the model for all. Just you see, model. There is a 3 model we develop. So FID1, that is a predicted, then FID2, that is the crop age at the, just you see this, the graph of this observed and with the crop age at the peak population. Just if you see this graph, now you see the graph, observed and the predicted is a very much close to the observed and predicted for a mustard crop. So if we see the graph between the intensity, these are the graph between the intensity. You see the intensity. So in the last 2 years, it is a less than 0. So there is a very, very less than threshold value. That's reason it is a very low towards low number is there. So like if we go for the Sri Ganganagar and then choose the date year 21 and then see this crop age at the all. If you see again all. If you see all, so again you will get the large number of, you see my model R square is a 0.9. There's a various factor there, and these factors are important. That's I will demonstrate to you. Just you see this, the graph. If you see the graph, these are the graph between the observed, and it is almost capturing the phenomena. But if you see the graph for the predicted at Y2 means crop age at the first appearance. So it is a, just you see, it is again very, because 21, very, very less amount was there. Just as in prediction 2021, we predict only 102 feet per trip. So that is a very low as compared. So sorry, no, this is in days. So it is in days the observed. So if you see the graph between the observed and predicted for this numbers of observations, if you see, so it is a predictions of the intensity of this. So we can tell the predictions based on the intensity, based on the monitoring, based on this. Like similarly, we develop a cotton also. So in cotton also, we develop a model for a different districts of just like a Karnataka. We develop the model for a Karnataka as well as for the Maharashtra. So you see the Karnataka. We develop a model for different districts of Karnataka, taking from there is 30 districts in which this cotton crop was, means almost all Maharashtra and Karnataka crop was there, but here we use this model. So we develop a model for a aphids, jessid, thrips, pink bollworm, and the cotton bollworm. Similarly, for the Maharashtra, if you see, there are 34 districts models was developed, starting from the all districts of the Maharashtra, except few we not consider in the model because data was not available. So here for Maharashtra, the aphid, jessid, and thrips, based on these 3 pests like aphid, jessid, and thrips, the crop age at the first appearance, crop age at the peak population, the maximum population was developed. And now you see, again, if we select so under this, what we have selected, that is a cotton was selected. Now I have to select anyone like a aphid, thrips, jessid. So if like it to be a jessid, so if you select a jessid, it will ask which locations you want. So if we go for the Maharashtra, it will come to the numbers, which districts you want to see the predictions and development of model. Let it be a Latur of the Maharashtra. Then it will tell in which year you want the predictions. So then again, because for a Maharashtra, we develop model for Y2, Y3, and Y1, Y2, Y3. That is a crop age at the first appearance, crop age at the peak population, and the maximum intensity of that crop. So using all Y1, Y2, Y3, we develop a model. So if we select a model for all, so it will tell us the just you see by predicted value. So now we are interested in Y2 and Y1. Just you see the graph of the observed and the predicted for just you see. Now you see the behavior of the observed and predicted. It is a very closed one. And you see the model tell. The model tell us about the 0.89, the accuracy and the prediction of is 0.2. These are the mean absolute percentage error in numbers. So it is up to the limit. So we can see this, it is the prediction was a very good as compared to the observed one. So there is a good agreement with the observed and the predictor. So if you see now you see these are the populations. So populations also increasing, and some year it was decreasing. Then again, yes, you see 2007, our predictions very low, but in 2018, the predictions were, our prediction was very high. And that's the reason you say it is a, in particular year when the condition was not congenial, the prediction, the intensity was low. But in some year when the intensity was very good, means the climate condition was very favorable, it is increasing to a great extent, and that season it damages the crop. So nowadays, this is the scenario of just you see in the 2005-16, the intensity was low. But after reaching to a 10 and 11, intensity become very higher as compared to the previous year, because maybe it's some, as you know, because of this BT cotton in initial state, it was a all our sucking pest was not there. But as the times increasing, the sucking pest become a more and more problem in the BT also. Like this is my observations while working in this area. Like this way, pigeon pea, chip potato, rice, and similarly or rice. If you see, we develop a model for the rice. If you see the rice here, we develop model for the yield predictions for all 75 districts of UP. That is the, because otherwise it is a very difficult to get a setmet day, any weather data on that one. But the setmet data is the very good platform where you can also utilize the model for whole districts wise. So like this way here, district wise, because the pest forewarning we develop for the Chhattisgarh, West Bengal, and Tamil Nadu for all districts, like see, all districts of Tamil Nadu, West Bengal, Chhattisgarh's district was there. So you can think on that direction also. If you go for the, so rice, chickpea, pigeon pea, here all we considered for the last 3 years we work on this model project, and maybe in this March, this all everything will be maybe we get extension for 1 or 2 more year for this type of work, because it was a tell the real picture scenario at the farmers fields. It is not, this model was developed at the based on the you can say the experimental stations, because here the weather data in the real ground we have considered, and based on only the weather data will tell us. And we also try to improve the yield production using the NDVI, the LST temperature, the less surface temperature, and other things. That is the beauty of this type of model which we develop in this scenario. This is the one aspect where I want to show. Then there is another thing which I want to share with you is the climatic conditions based model, where we develop some model using the projections of the conditions. So before that, just I will tell some theory so that you can also get the awareness. So these are the thumbs rules. These are the model which we develop. Just now, see, just one demonstration. These are the another approach which we work under the ICAR CIMET. These are the development of warning model for a pest and wheat. These work is the first type in India because normally the wheat is free from the all type of pest. But due to maybe the climatic change and other thing, CIMET has given one assignment for the development of the mustard aphid. Like a similar type of work which he did in the mustard aphid, can we develop a model for the wheat aphid? Based on this, we consider a 3 location, that is the Pantnagar, Ludhiana, and Nifed for the wheat aphid. And now see my predictions and observed one predictions. Just you see, it is a very much close to the observed one in almost all the districts of different locations of the target locations like Pantnagar, Maharashtra, that is a Nifad, and the Uttarakhand in Pantnagar. So,
hello, sir.
Yes, sir.
Yeah, small request. That tea has come and it is getting cold there.
Okay, no issues.
Can
No,
we take a small break, sir?
No issue. At what time should we resume?
So exactly 10 minutes we will be back. Maximum
Okay,
15 minutes, sir.
No issue. No issue. Maximum 15 minutes I will be there. Sir.
15 minutes.
Okay.
Thank you, sir. You also please have tea and be ready. Okay, thank you. Hello. Dr. Amarender, sir, if you are hearing me, we are ready from our side. Okay. We are ready.
ये स्क्रीन आपकी शेयर हो रही है?
हाँ, ये चल रहा था ना, 10 मिनट ब्रेक हुआ। म्यूट कर दो
लो सर।
म्यूट हो गया।
मैंने म्यूट कर रखा है, वैसे तो म्यूट और वीडियो कैमरा दोनों ऑफ कर रखा है।
यार पता नहीं वो वीडियो
ये
कैमरा on
ये
नहीं हो रहा है।
क्विक हिल आपने क्या किया, अनइंस्टॉल
उसको-
किया?
नहीं नहीं, वो अपने आप चलता रहता है, इसको चलने दो।
एक बार बात करके देख लो। ये मैंने मिनिमाइज कर रखा है, जूम होगा यहाँ पे। ये रहा स्क्रीन, हाँ यही, इसी पे करो। ये हाँ, ना क्लिक, हाँ यहाँ पे मोर, पार्टिसिपेट, वीडियो ऑन करना सर, यहाँ पे जाके दोबारा एक बार वीडियो। ठीक है, अब एक बार हम बोल के पूछ देख लो।
हाँ वीडियो आ गया। हेलो सर, कैन यू हियर मी?
Yeah, yes, sir, yes, sir. And we are hearing. Please go ahead. Yeah.
छोड़ दो।
नहीं, एक बार दोबारा मैं चेक करूँ, क्योंकि कनेक्ट तो हो गया, उसमें आवाज आई थी मेरे को।
You are audible, sir.
एक मिनट सर, एक मिनट, बस एक मिनट और दीजिए सर। कनेक्टेड म्यूजिक है ना, ये एक कनेक्टेड है सर। एक मिनट बस, मुझे एक मिनट।
I will start with that.
आप ये फुल स्क्रीन कहाँ से होता है सर?
चलो रंजन।
नहीं नहीं सर, एक मिनट रुको तो सर। हेडफोन ये है ना, अब बोलो।
Hello.
Hello.
Yeah. Okay. Thank you. So, bye. Thank you. So, should we start, sir?
Yeah, yes, sir, yes, sir. Please go ahead. Yeah.
So, just you see, these are the. I think it is a visible screen.
It is visible. Yeah.
So, this is the slide in which we work on the wheat feed. So, which is a wheat feed is nowadays not a problem in India. If you think on the last 10 to 15 years, if you think, we normally heard that wheat is a free from the pest. But now there is one problem starting with the from the Bangladesh and even in the African country or some European country, there is a major problem of the wheat aphid, and that damage the whole crop. So because of this, because the importance, so wheat aphid, because of the climatic change, it become from the minor to major pest. Initially at the American state, then later it used to the European. Now it is in Bangladesh, it is a major problematic, and now it started in the India also. So that's the reason we started with the CIMET India Center with the BHU and the IRA as a center for development of the food monitoring system for the wheat aphid. And in this case, again, we developed the model for the three scenario. One is the what is the intensity of the mustard aphid for 3 locations? What is the crop age of maximum population of the wheat aphid? And third is the first appearance. And from the first appearance, we started working on the weekly monitoring of the wheat aphid. And now just see this graph is showing there is a good agreement with the observed and observed one with the forecast one. And based on this analysis, we just now published one paper on the experimental biology of this model. Just recently, 1 month back, this paper was published. And this type of work is the first type of work in the India, which is especially on the wheat aphid. So here again, we are using the indices-based approaches which take care of the weather data from the time of sowing to the time of warning. So here we are not losing any informations on the weather climate conditions taking from the sowing. There's normally what I feel that the 2 weeks before the sowing will also consider in the model development, and we develop indices which take care of the each week data. Sometime we are like in rice blast, we develop one model that is a case study was we develop. In this case, we take a data for every 3 hours data from the setmet data, we develop a model. So now you see, so we develop a model for a 3-week model in which every 3-hour data was utilized on the model development. So this is the one beauty of this indices, weather-based indices model, which take care of the phenomena in a very close manner, which is very close to the observed one. This is the one aspect just I want to share with you. Then these are the different, just you see the deviation from the observed one for the wheat and the barley in the different location. You see, it is up to a, so see the MAP. So when what is a one, Y1, Y2, Y3. So Y3 is the population. So population fluctuation was there. So it is a little bit high, but it is under. But this 20.6 is still to be a very high, good quality, good amount, very close to the observed one. Similarly, you see Y1, Y2 it is, and so wheat aphid in Ludhiana, you see how much accuracy we develop model. Similarly, barley aphid is a 7.6, wheat aphid for Pantnagar is a 10.6. It is a very close to the observed one with respect to the mean absolute percentage error in the model. So similarly, we develop a model for the BT cotton. These are the difference, what was demonstrated in the satellite-based data. This model was developed to a great extent for the aphid, leafhopper, thrips, and so these are the deviation just you see, the average deviation just you see for whether it is take for the aphid, leafhopper, or thrips. So it is a maximum of the 10.2 for the maximum population of pest. Average deviation is from the crop age at the peak population of the aphid. Just you see, it is a very close to the observed one, whether it in terms of the MAP, whether in terms of the. These are the most important things which I want to show to you. These are the pattern development, how the pest and disease is progress. So just I will tell you one example. So I will demonstrate first, then I will show to you. Just a minute. So what is this? Just you see. Oh, where is that code? If we plot a graph between the population, this is the population and this is the time. Population or intensity of disease and population of pest. So if you graph between the pest population / intensity of disease with respect to time, you will find that this is a look like by this method. This is related to disease. This is related to the pest population. This indicate at the initial stage, when at the zero initial stage, the population and the intensity of disease will be very small. But as the time goes, as the crop growth was there, so the population will increase to a peak population. Then there is a decrease in the pest population, and then if under the disease it becomes the saturated. So we are interested in these things. So let it be a 0 to 35 days. So let us say, normally if you plot the progress of the population on the year wise, every year this type of shape will be there. I think you are agree with this one. So now we see what is this shape. This shape is a S-shaped curve. This is an S-shaped curve. It is not a linear in nature. It is basically a S-shaped curve. And now S-shaped curve are mostly the sigmoid family. And because then what we consider, so normally these pest populations, the relationship between the pest, weather, and the crop is not a linear in nature. It is a very complex as well as non-linear in nature. So keeping these factors, the phenomena of the population's dynamics, we start with the another approach, which is known as the pattern development. Pattern development, so that we can get one pattern of any pest and disease. Based on that pattern, we can tell as the maximum intensity and time of sieve spray. These two things we can get from the pattern development model based on the S-shaped curve which I have shown to you. So can we get this maximum intensity and the time of spray? If you think, so just like we develop one model, just I want to show to you. Because as you discuss you that we want the pattern development. So just you see that my deterministic model for the population growth is this one. So pattern development population growth in wheat is NT AE minus BT. So here A and B and D is the my parameter. A is the intrinsic growth, B is the birth rate, death rate, and D is the my patterns. A pattern over the crop should be there. So there are three parameters which have to be estimated from these equations. AE minus BT plus 1 plus DE minus BT by 2. So there are three parameters if you see, and based on these three parameters, if you make a parameter of A and 4D, we know from this model, we can estimate the A and the D through a non-linear intrinsic growth rate model is there. So we can get the Nmax. Nmax means what should be the population of the pest in that season. And the T realizes the optimum time of insecticide spray. The T is a B minus 1 log of D. If you get these three things, based on these three things, we can get the informations on this model. Like just one, see, I want to show one. So using this, we develop for the wheat aphid pattern, and based on this non-linear pattern, we also get the what should be the maximum number of wheat aphid in that season, and what should be the time of spray based on these three parameters. This can be also done through a non-linear development model, which is known as the pattern development. Then these are the principal component analysis. I will not want to take on these aspects of populations. These are the very important one. Normally, those who work in the pest and disease dynamic, they get a large number of information on the qualitative data. So how this qualitative data be converted into the model form so that you will get a very good information on the modeling aspect on this one. So in this case, we also work in the different type of disease. Recently, we did one complete work on the pod damages. It on the pigeon pea. So there is one disease. I want to see which disease it is there. Oh, sorry. This is the data on the pod damages by a pod borer. Pod damages by the pod borer for a Kanpur center. So here what I did it, we divided the data into two groups. So we divided the data into two groups, that is a 1 and 0. If it is a pod damage is more than 50, it is a 1, and if it is less than 50, it is a 0. So based on these two, we have divided the different year data from the 1987, 88 to 2009 to 10 into a different groups like a 0 and 1. One deals with the epidemic status. If it is the percentage is more than pod damage, percentage is more than 15%. If the pod damage percentage is less than 0%, it is considered as a 0. And based on this, we develop a weather indices, and using the data from the maximum temperature, minimum temperature, relative humidity, rainfall, and breath sensor. Here you consider the 6 weather data, temperature 2, relative humidity 2, rainfall, as well as the bright sunshine hour I also consider in these cases. And based on these two models, we get a probability. Just you see, when we use the data from the 45 to 1, 45 to 2, 45 to 3, 45 to 4, means we using the weather data from the 45 standard meteorological week to 1 standard meteorological week of the next year. Then each year we added, and now you see, when we consider the model up to a 45 to 1, its probability indicate a 0.90. But when we increase the weather data by 1 week, its probability is a decrease. It means that this is the ideal time to forecast. Based on this model, this is the ideal time to forecast. And here you see our observed status is 1, and for warning status is a 0.93 with 1. So different year, the probability is giving a very good example in these cases. But as we giving more and more data, that become the complex. So we can forecast the pod damage using the weather data from the 45 standard meteorological week to 1 standard meteorological week, with the probability that it is a 0.931 and with status observed. So there we develop different models, and these are the out of sample. That's testing of the model in the 2010-11 and 11-12, and you see these predictions. So using this logistic also, we can tell us the epidemic status, whether that will make an impact on the crop or not. So based on this, we can also Now you just see this model. So overall, if you see my status and the probability, so in 1987, the pot damage is a 22.1. So we put it as a 1. So in this case, where is less than 15, we put a 0. But now you see the probability. Also see the probability where over this model work. So in this model work, so you just see the 1996, there is a misgap, but you see the probability is a 0.48, which is very close to the 0.51. But you see in 99, 2001, 99 and 2001, it is a capturing both at exact means 0.32 with a 0.1. With the observed one is very close to 1. So this is also one approach in which when we have the data on the qualitative nature, qualitative information we have, based on this qualitative information, we also predict a model using the logistic regression. So this work which is published in the Indian Journal of Agriculture Science in 2013 and 14, and this citation was very high because a lot of people are using this model to develop their own paper or they utilizing in the product development. These are the within-year model data. Within-year model data means when we have only 1 year of data, how this progress can be done. So these are good for our students' research, for a pattern development, but not for the predictions purpose. So in these cases, we use normally this type of model A exponential, just you see. So in this case, what we try to do, how the peak severity will be there. So we find that the peak is a severity is reached at a 7th week. Can we predict this model with the time period of 5 or 4 or 3? That is the beauty of this model. Means when the peak severity is reaching at the 7th week, but we can predict this 73.55 at the less than the 7 week. So we can predict this at least 2 weeks in advance. So this can be predicted at a 5 week. This can be predicted at a 5 week. This can be predicted at a 6 week. So when we reach the 6, the data from the 6th week, we can predict the real events which will appear in the 7th week. So 2 week advance, we can tell us the maximum disease severity based on this model. So here, this model I using the A exponential minus B. These are the non-linear models. Based on this model, we are develop the graph, develop a pattern, and based on that pattern, we will try to predict, not predict, we will extrapolate based on this parameter A and B, what should be the maximum intensity. So here, based on this analysis, we can say that the reliable forecast or not forecast, the reliable predictions of a maximum PDS could be obtained 2 weeks in advance. Means when it appears at the 7th week of standard meteorological week, we can predict at the 5, means 2 weeks before, we can tell us what should be the maximum intensity for that disease that can be done. So these can be used. Then there is another approach, which is nowadays very much people are working on this aspect, is artificial neural network. That is known as the machine learning approaches, where it is not an assumptions-based model like a statistical modeling or any error model. When there is a based on some assumptions. Our data should follow some distribution, like this type of assumptions were there. But nowadays, there is a technique which is known as the artificial neural network, or which is a group of the soft computing technique. They tell us that the data pattern, they develop the pattern from the data itself, so that is known as the data-driven technique. Then there is no need for the assumptions of the data. It is an assumptions-free model, intelligent, dynamic, assumptions-free system dynamic model was there. So this type of work, artificial neural network and the classification regression tree, that is known as the CART, then fuzzy regression, integration of the neurofuzzy, the pattern development, all these are the non-linear in natures, and these all are developed through a data-driven technique. So I also utilize this type of model in the predictions when we have the huge data set. This is the one major problem in that we should have a good amount of the data so that it can learn, it can generalize the information to the end user. So 2-3 things that this slide I will tell you want to show. So students, I think all of you know neural network, how the brain works. So these you know much better than me because you are the biological scientist, so you know much better than me. So, but I will tell us, can is possible to develop a model, the behavior of the brain, how work was done by the brain. The same thing can be done through some modeling, and that is some mathematical equations. So if we put that in the mathematical equations, the brain working nature of the brain to a mathematical model, that is become the artificial neural network. So now the question comes, why these neural networks are desirable? So neural networks are desirable because human brain can generalize from the abstract. They can recognize pattern in the presence of the noise. They can recall memories. They can make decision for a current problem based on the prior experience. So you just see the last statement. What is it? Make a decision for a current problem based on the prior experience. It means that based on the some learning capacity the brain have, based on the learning capacity, they make a decision. So they first develop a pattern, and based on that pattern, when future data is coming, they put that future data in the pattern, and then will give a predictions. So because of this effect, which make a decision for a current problem based on the learning experience, he can recall the memory, that can generalize, that is, learning can be done. So he can recognize pattern in the absence of noise. When the data was not up to the mark, then when there is a lot of error was there, then again it can recognize the pattern. And because of this desirability and because of the statistical predictions, what is the importance desirable in the statistics? We want to predict the future event based on the past experience. This is the future desirability in the statistic. Third is able to classify pattern in the memory and the non-linear regression problems. Basically, if you see the complexity of the agriculture or the behavior of the neuron system, it is very complex in nature, and it is not a linear in nature. It is a very non-linear in a nature. So thus non-linear regression problems, able to classify pattern in the memory, predictions of futures event based on the past experience. These are the statistical desirability which we want, and based on the neural network, these are the some combined together will come to a group of artificial neural network where we can develop a pattern based on the data, which is through a training process, and based on the training process, we can test the future observation, and thus comes to a artificial neural network. So how it work? So just you see the application. Nowadays, if you see any area of science, maybe agriculture, engineering, optimization technique, biological science, hydrology, economics, exchange, anything you see, you will find that there is applications of ANN. Starting from the classification process, you see nowadays the medical diagnostics, signature verification, face recognitions, image recognitions, risk evaluations, data mining, voice recognitions, all these can be done through a ANN application when we talk about the classification. Similarly, when we go for the modeling and the controlling, like a engineering aspect, optimization technique can be done through a control system, system identification, composing music also. All are done through a control and modeling. And then in the forecasting purpose, economical indicator, future energy requirement, crop forecasting, medical outcomes, environmental risk. Think of any area, this technique was available, and This is a so vast nature, and the accuracy is day by day it is increasing, because we have the very fast computational ability nowadays. So when this technique was evaluated in 1948, the computational ability was not there, learning pattern was not there. That reason it was not. But in the 1980, there is a process of learning. Learning concept was there through a back propagation was introduced. After that, the ANN became a boom in the all aspects. Nowadays, everyone is talking on the AI-based approach, artificial intelligence-based approach. And then artificial intelligence, these are the brains, which is a work in the artificial platform. And based on this, everything is done by maybe classification, maybe forecasting, maybe image recognition, face recognition, character recognition. Anything you can see can be done through this type of the approaches. So these are the mathematical notations. So these are the basic architecture that I want to show to you. Just you see how it look like. It is a look like how the brains are connected from in one input to the another input to the next input, and then finally the output. So these are the basic architecture of the neural network, in which they are connected to each layer. Connection was there. So the input from the one layer to the second layer to the output will reach, and then it comes to a conclusions like this way. So how this learning can be take place? So just you see, these are the mathematical representation of it. So these are the so initial stage, if you see, these are the summation sign indicated the my input there. Then there is a non-linearity was introduced, that is the second stage, and finally the output was there. So this represented the mathematical representation of the neural network. Just I want to show. These are the various steps which is required for the neural network training, testing, and validation set. Just you see, in the training test, the 50% of the data was trained. Based on the trained data, model was developed, and that model was tested and validated in the different sets are there. So just you see, data is divided into the three tests. First set is known as the training set, which represented the input and output map. The test data required to decide when to stop the training network and not for wait update. This is the difference between the test data. And validation set is the part of the collected data that is a set aside to test how well is the trained neural network model. So first two is a test for the performance of the model. Third is the out of the sample data. So these are the algorithm. So how the learning algorithm can be done? So the learning can be done by this method. So when there is a input, it reaches to a NN model, then it routes to a output vector. That output vector is a target, take care by the target vector. And if this difference is the more than threshold level, it's again come to a weight. Again, the weight was adjusted, and this process continues till we reach to a tolerance limit. And when the tolerance limit was reached, this process was stopped, and this learning can be done by the back propagation, 11-word multi-rate conjugate, gradient descent, weight decay learning algorithm. So these are the various learning algorithm which is used for the learning in the data for the pattern development in an artificial neural network. And these are the algorithm or the screens the process in which how the input is go to the ANN model, from the ANN to the output vector, from the output vector, the target vector, through the, if the difference was the more than the threshold, it again reached to a rain model, and this process was continuous till the end of the learning process. Just these we developed for a large number of model was developed based on these predictions of using this artificial neural network. These are the example for the we develop. Okay, just an example that I will tell you. Here, what I did it, I want to see the my character of intersection is evaporation as a target, and as you know, the evaporations is a meteorological variables which is a functions of maximum temperature, minimum temperature, relative humidity, evening, morning, one sunshine hour, and bright sunshine hour. So these are the inputs. So my target is the evaporation, and my input variable is the max, mean, RH1, RH2, rainfall, BSH, and wind speed. These are the my target variables. So in this case, what I did is I developed a multi-layer perceptron tech architecture with a two-phase algorithm for a back propagation and a conjugate gradient for learning, with a hyperbolic function as an activation function. So these are the my brain where which this non-linear model was performed, and based on this various combination of input variable I consider as the mean temperature, different set of the data I study in these cases, starting from the mean temperature, mean relative humidity, bright sunshine hour, and the wind speed. In the one set, I use the mean temperature, mean RH, and bright sunshine. So like I make a different combinations, 1 to 4 combination, and I use this model for a, just now you see the performance. So I here for whole complete year, I use for the prediction purpose evaporations in terms of the evaporation. So you see the Bangalore, Una, Raipur, Pantnagar, Anandpur, and Karnal. All are from the different agroclimatic zone models. Just you see. And now you see the performance of all this Bangalore, Raipur, Una, Karnal is a very, very clear cut. If you see the observed and predicted, there is not too much deviation. But when you see the difference between the Pantnagar and the Anantapur is near Karnataka district, I think it is this one data, the division was a very high. You see the division in this Pantnagar and the Anantpur was very high. Then I see what is the reason. Then based on this, I see that for the Anandpur, because of it is close to the equator, there is another factor which I have not included. The model may play important role. That reason this connect was not there. Similarly, for the Pantnagar, you see from the 1 to 25 week, 1 to 25, the predictions was very close to the observed one. But from the 25 week and onward, the prediction was not very good. What I feel that because of some climate, because this is some hilly area, that may be the factor which this cannot be captured in that upon. And based on this analysis, which we have published this model in the Sunday Communications, and which was published in the Mosam journals, whose mass rating is about 0.75, and which already published in this journals. And here I see because ANN can perform better when we have the huge data set of data. So here we have the 20-year data on the weekly basis data. So we get the more than 1,000 data observations. And based on the 1,000 data, we develop model, and now see the performance of the model is very good. In this case, as we see, compare with the regression model. And if you see the mean absolute percentage also, if it is there, I will show to you whether it is there or not. It was not there, but it is very close to the, if you see, it is within the less than the 5% of the mean absolute error MAP on the basis of this model, except for the Anandpur, rest was the very less than the 5% was there. And based on this, we find that this ANN approach can be a good alternative tool compared to the predictions model for the forecast of pest and disease well in advance. So these are the card I want. I also developed some group-based model, like a thumb rules are there. So thumb rules are the subjective in nature, as you know. So can be this type of subjective nature or model can be put in the objective model. So this is the approach where the subjective nature can be put in the objective manners. So here I using the CSE minor for development of this different aduturai. Here I use for the rice pest, that is yellow stem borer, for a different location. I develop for aduturai, Chinsura, Karjat, Mandya, that is the one Karnataka, and then Ludhiana and Raipur. I analyze, I group in the, like this way. Based on the model or the whatever the data we have, I divided into the different set of population. So what I say that if the Raipur, if more than population was that north catch per trap is more than 1,000, it is high. Moderate 100 to low. Under this condition, if you find that if the maximum T max is like this one, T minimum is rise between the 20 to 23, RH1 89 to 92, rainfall 0 to 10, and sunshine about 6.9. So I make a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I make a 5 criteria. More than 3, less than 3, if it is there, then it is say we can say that it will be a high, moderate, low. That is my point. So what I predictions rule say that more than 3, it is a high. If it is a 3, it is a low. Sorry, moderate, and less than 3, it is a low. Based on these 3 criteria, if more than 3 criteria fulfill, the intensity or the pest severity will be a high. If the 2 criteria meet based on this, we say that it is a moderate. If it is a less than 3 criteria meet, we can say it is a low. So here, from the subjective nature of the information, we will convert it into the objective nature of information by making some rules. And based on this rule, we make some rules like this way. Also, we develop for the Spodotra Lutra groundnut. Junagadh, I make a 1, 2, 3, 4, 5. 5 rules I make. Like a maximum temperature, if it is lies between the 25 to 28 degree, minimum temperature less than 19, more than 19.5, relative humidity more than 90%, evening 78 to 83, and total rainfall less than 20. Among these 5, if all parameters fall under that evaluation, then we can say that the population of Spodotra lupra is more than 400. If 4 out of 5 criteria fulfill, then the population will be 200 to 400. If the criteria rules say that 3 or less based on this developed criteria, we say that 200, then there is intensity of low. Any doubt? Hello, friends. Any doubt till this point? Hello, Sridhar sir.
Yes, sir. We are with you. Any doubts? No, sir. You can go ahead. Yeah.
Okay. So, how much time I have to there, sir?
Maybe another 15 minutes. Okay, sir.
Okay.
15,
then I will
20
try
minutes.
To,
yeah.
So one thing that I want to that is climatic effect I want to share with you.
Okay.
So all these just you see, these are the things which you have already told, but here you can convert your subjective nature into a objective nature by making this type of analysis. And all this analysis is already available in the literature, but you have to take some initiatives and come with new ideas. And that's the reason it will be help to enhance your knowledge, and directly it will benefit to the end user, maybe the policymaker, maybe the farmer, for when we develop, they think in the pest and disease prediction type of model. These input I'm not want to show in detail. Sorry, see what happened. Now I will tell something about the remote sensing to forecast pest. Already before there is one full-fledged lecture by Dr. Prabhakar. So therefore I will not come to detail of this aspect. So, but I will tell us what I did in through remote sensing. I did not develop any images. I got the images. From the images, I converted the data from the images to the SatMet agromet product, satellite-based agromet product. That is how, based on the satellite data, how we can get that temperature, minimum temperature, maximum temperature, relative humidity, morning relative humidity, cloud cover, rainfall, total cover, precipitation, and the bright sunshine hour. Like this way, we through some algorithm which we developed. Through that algorithm, from the satellite data, we converted this data into the satellite-based agromet product. And that agromet product we will utilize instead of the agromet data, because it is difficult to get the agromet data for each location. But through a satellite-based data, if I want to get the data through a satellite for the IRI New Delhi, I can get the data for the IRI. If I want to get the by the 5 by 5 kilometer grid point, I can get the data. So if you put the 5 by 5 grid data for all over India, we require millions of the satellite agromet data center, but that don't be feasible. So that's the reason we are using SatMet data for the prediction purpose. And you know, these are some basic information about the meteorological evaluation is valid for a 75 kilometer. And thus we have the 127 agroecological zones of India, and we require 1,200 observations from multi-year observation or disease, epidemic, insect, pest, epizootics in these many locations. So it is a very difficult to get these type of putting the data, putting the center, putting the agromet sensor, and that is very costly. So what we plan, we can get a SatMet data, and we can just see what we did. So we start with the two diseases. One is the mustard aphid. Just we did for the whole Rajasthan and the Haryana, and here use the satellite-based product, and based on that we predict the aphid forecast and Alternate forecast. Then there is another disease which we use the use for the Sclerotinia rot detections, and here we using the hyperspectral images, which is through a hyperspectral images we identify the healthy versus the non-healthy plant, and for each disease with a difference you see. At the 7th January, there is too much difference was there. At the 24th February 2005, the difference become very less. So you see, based on this, you see that they are very close to observe one. So then we can say that they are the healthy disease, unhealthy disease, like intensity was 0, 0, 0. But when this, you see the MI was 45, 20, and 5. So they become very close. So for each wavelength, we calculated the spectral images, and based on that spectral images, we can identify the disease versus healthy, and then based on this, we can identify this Sclerotinia rot in the field to a large area, not for a single area. That is the one beauty of this, which we did. Like this way, we can get the forecast crop pest. If you see, based on this, here just see, I also saw the one exercise for whole districts and other things. So these are my results. Operationalization we did for the 14, 5, 15, 16, 16, 7. It is a very close to the agromet, and observed, if you see SatMet, by making a correction factor, we find that the observed and the predicted for this operationalization of model means we validate it and we give advisory to the farmers for the 3-4 years. Similarly, here you see the Y3 244 and the SatMet data 277. Similarly, for the 65, 70, 73. These are the observed population of the mustard aphid is a 65.5 per trap per there. So my model say it is a 65. My model says 70, and my settlement date model says 73. So these are very close to the observed one. These are the set system I have to. So these are my one case study just I want to tell you. So this is the we developed for the 20th February 2017 with this. Now you see the forecast for a aphid population for 1670, it is a 177.8 aphid per centimeter per shoot. Just you see this we forecast in the second week of January. These are the four basically photo on the 20th February 2017. But we forecast it in the second week of January. That this will be the population close to this one. So what is the map? Forecast 177.8. But what is the actual infestation? 191. Got it? This my forecast in the month of second week of January, I say that the aphid infestation will be 191. Sorry, 177.8. I forecast for a infestation of the aphid population 177.8 aphid per 10 centimeter shoot in the month second week of January. But on the 20th February, I found the maximum population is reached to 191. It is very close to the observed one. Similarly, for Bayana, I forecast for a observed one is a 169, and really it is a 177. Infestation aphid is a 2005, and my forecast is a 177 point aphid. So it is very close to the observed one. So like similarly, we did for the chickpea in the crescent field for the last 2 years. And we find that it is a matching with the observed one. So here we can go for the different district, different locations. Even we can go for the block level, or if we have the data, we can go for the village level infestation of that disease or pest in a particular, if we use the satellite based data. Now, these are the important things. Now we said there is a climatic change. Everyone is asking climatic change was there, climatic change is there. So how we detect this climatic change? Is there any phenomena to detect the climatic change, or any information is there? So basically very simple things I will tell you about the trend analysis. And you know there is a null hypothesis that our function is a constant, and alternative hypothesis FT was not constant. So that is my alternative hypothesis. So we can make a trend analysis plus a stochastic variables and trend plus error. If our deterministic function is a time and the stochastic variation is a random variable, then my FT plus IT. So if my FT is a constant, then there is no changes. But when this FT is not constant, it means there is some changes. So simply parametric and through non-parametric, I try to get the trend analysis in the climatic variable. So now how I can get the climatic variable changes? So now you see, we get the data for the 40-year data for a 4 to 5 location on the maximum temperature, minimum temperature, relative humidity, rainfall, and sunshine hour. So what I did, I converted the data into the weekly data, seasonal data, and a monthly data. So in the weekly data, I have data from the 1 to 52 standard meteorological week. In the seasonal data, I have the Kharif, Rabi, and summer data. And in the monthly data, as you know, January, February to December. So what I did, so theoretically, I will just skip it. It is difficult to you understand. So just directly, I will come to this. Just now you see, based on the In this table, just you see two things. One is my, okay, just I want to see what is S1. Just you see what is my S1. Okay. S1 is Kharif, Rabi, and summer. Okay, maybe. I think there is some confusion was there. No, just see seasonal data. Here what I make it, I take a different three seasonals, S1, that is a Kharif, S2 is the Rabi, and S3 is the summer season. Similarly, for maximum, minimum, RH1, RH2, rainfall, wind speed, you see, just you see my trend analysis. I found that for a maximum temperature of seasonal 3, the p-value is a less than 0.11%. It means that the seasonal deviation was a very much high in the maximum temperature as compared to S1 and S2. So there is a trend in the S3 in the maximum temperature. Similarly, relative humidity, similarly with the wind speed, that this is what there. So just you see in detail. Now it comes to the weekly. You will get surprised. As you know, these are the weekly data. And you know, these are the my Rabi season, 40, 41, 42, 46, 47, 48, and these are the my winter time. And this data is for the Hyderabad data. Now you see my red color. It means these are the winter season. And we find that these are the for a weekly trend for the temperature. I'm talking the weekly trend for the temperature. These are the temperature data. And we find that from the 46, 41, 42, 46, 47, 48, that is the month of the November and December, there is a increasing trend in the temperature. This data I have taken from the ICAR-IIHR Hyderabad data for the last 40-year data. And I divided the data into 3 different weeks data. And now you see my week data. Based on this, there is a clear-cut indicate that during the winter season, the temperature become higher. It means that over the temperature or the winter season is reducing to a great extent. The temperature changes was very, you see the Z value, 2, 3, 2, 3, 2, highly significant. Means during this 46 to 51, 52 of on almost all last week of December and January first week, it is a very, temperature was very much fluctuated to a higher side. So we can say that the winter is going to be reduced in that area. So we can analyze based on the district wises by this method and come up with a conclusion. Now, because of these changes in the temperature, there are some disease or pest. Those which become the minor, they can become the major based upon their life cycle. If within the frame of the life cycle, if the populations or the generation will be increased, then it means that for that population of a pest will become a minor to major. Those populations generation within a time period is going to reduce. It means from the major, they're going to become a minor based on this analysis. Again, I'm repeating, based on this change in the temperature, their physiological changes will be there. If the based on this physiological temperature within a particular time frame, if there is a generation is reduced to 1 or 2 generation, their population will become deteriorated and that pest become from a major to minor. But if this phenomena is a reverse in direction, that it means that that particular disease or pest, those which is in a minor can become a major in the coming year. So these are the climatic changes aspect of this weather factors we did for the 12 locations, mainly for the pigeon pea area and as well as the rice area. So I'm taking a 12 agroclimatic zones, and from the each zones I taking a 40-year weather data, and based on this 40-year data I try to get this type of analysis. And this type of analysis which I have published in the Mosam Journal in 2016 or 17. So now, whatever the model I developed, I put in the different systems. These are the my architecture of the system. So in my system, how it works, it take a data from the station. So I directly take a data from the either IMD or from the SetMet data. I put my database in this databases. From there is a application logic layer, and from the application logic, the client side was there. So they are connected through a system, through a PHP platform, or HTML. From HTML I shifted to the PHP basis coding system. And these are the architecture of the software, starting from the client side interface, whether database layer and the application logical layer. And with this, we develop a model, which I have shown earlier how it works. So these are the different architectures. These are the different set of the system which we developed. And I also demonstrated some of the system, which is based on the spatial data, which is based on the some climatic change data. So like these are the web-enabled system for the crops, which I have shown to you. Now just you see what I did. Based on this, I can give advisory also. Like you'll see. Now you see. Based on this, we developed for the system recommendation for a mustard feed pest in 2008 for a Bharatpur location. So we find that the population will be about 192.5 per trap occur after 118 days of the crop sowing. So what should be my advisory? So I put my advisory. This can be disseminated through the mobile app, through SMS to the end user well in advance, so that a crop can be saved to a great extent. So from there, we develop a model, get the forewarning. From the forewarning, we can connect with the database of the advisory, and that advisory can be communicated to the farmers for their further analysis. These are the developed models which I developed for the Vedas, means with a satellite-based model prediction. So at a single platform, I can see which locations have the maximum intensity of aphid for a full Rajasthan. So based on the different 7th week, 6th week, which is available in the Vedas, which I consider is the one of the product of IRI, which is come through this satellite-based product, and which is placed in the Vedas system. So we also develop mobile app. Now to skip these things. So ultimate, my aim, just this is my aim, which I want to show to you. My ultimate aim is to create a national scale disease and insect pest forecasting. So I call it as an integrated decision support system for crop protection services. Here you see, I want to create a central hub. From there, I can get a data from the IMD, from the research, from the resolutions of different remote sensing and GIS, from the human resources. They come to a central place, that is not the central hub. And from this central hub, there should be a process, data should be processed. Then we can get a disease or insect pest alarm zone. And from this alarm zone, we can develop a agro advisory services to a national level. So this is the nutshell I want to see as a national scale disease and insect forecasting systems, which is my practical vision. And if this can be feasible, then we can give a alarm zone at in disease or insect based alarm zone we can be created, and from there national agro advisory service can be created, which will be very helpful to our scientific as well as the farmers community for the control of this measure. With this, I will stop it here, and thank you very much for this giving this platform. Thank you, Dr. Sridhar, for giving this.
Thank you. Thank you so much, sir. Thank you so very much for giving an elaborate idea about different modeling for first forecasting, forewarning, and yield forecasting. Everything you try to explain in a simple with examples. Also, he covered qualitative models, within year models, and data-driven models like ANN and other things. You stressed on even the thumb rules, particularly for some of the diseases. You went up to remote sensing for forecasting of pests, and you gave a glimpse of trend analysis also, which we all the plant protection specialists with the help of statisticians, meteorologists, we should know how this minor pest can become major and major pest become minor. In the last week also, we're trying to understand how this growing thermal degree days in different places, they may be positive for the pest and diseases, or they may it may be negative also. Now we are trying to understand which definitely help in understanding the impact of climate change and various biotic stresses. We thank you so much, sir, for giving an elaborate idea about statistical modeling. Now I'll request some of the participants, if they have any queries, they can ask after introducing themselves. Yes. Okay, sir. Just
okay, sir. Thank you.
Okay. Yeah. Anybody has anything? Yeah. You introduce yourself and yeah.
Good afternoon, sir. Myself, Arislan IGK Chhattisgarh. Sir, here we.
Sorry, I could not hear you. Sorry, I could not hear you.
I am clear, sir. I am audible,
Yes,
sir.
yes. No, you
sir,
are audible.
Yeah, sir. Here we. Hello.
Hello.
Sir?
Yeah.
Sir, here we have different prediction model for field crops, vegetables. Is there any prediction model for food crops, or what can I do for prediction for food crops?
Yeah, actually, Miss, I'm not completely here. You want the model for the fruit crops?
Yes, sir.
Yeah, actually, we did for the mango, plant hopper. We already developed, because these are the methodology. This can be implemented in fruit crop, vegetable crops, anywhere you can, because the process remains same. Because the pest behavior with the climatic condition, it remains the same. So if there is a congenial condition, it will come. But the occurrence will be different in the different crop or different vegetable and fruit. So that period of time, or what should be the time of forecasting, what should be the time for including in the model, that you have to consider, and you can utilize this model. There is we already developed for grapes. We did a good work in the grapes. We did a good work in the even the mango with the CISH Lucknow. We did a good job on this mango and the grapes. So you can also attempt another vegetable crop, fruit crops.
Thank you, sir.
Anybody else? Okay. I think everybody is through with our presentation. Once again, from all the participant side as well as from Division of Crop Protection IHR, I profusely thank you, sir, for joining and sharing your experiences in modeling for pest forecasting and warning. Thank you so much, sir.
Thank you, sir. So thank you, Dr. Sridhar, for giving this opportunity so that I can share my experiences with the faculty. Thank you very much, sir.
Thank you so much, sir. Then, okay. With your permission, I'm ending this session, sir.
Yeah, sure. Okay,
thank you.
sir.
Thank you. Bye.